What makes a cloud? A cloud is condensation in the atmosphere. We've talked about humidity. There needs to be enough water vapor in the atmosphere to form a cloud. We've talked about condensation. The temperature needs to get down to the dew point so that the particles of water vapor that are in the atmosphere, those molecules, are condensing into water droplets, forming a cloud. I can make a cloud at home. Let's go do that. To make a cloud in a jar, first thing I need is a jar. I need some warm water, doesn't have to be hot. I put that in the jar, and then I put a lid on top of the jar. And then we sit and we watch and we wait and we see water is condensing on the sides of the jar slowly. The sides of the jar are a little bit cooler than the water, and so the water vapor that's in the jar is condensing on the walls of the jar. And then when we zoom in close up, we can see those droplets of water on the sides. We can also see they are condensing into larger droplets and running down the sides when they get bumped into each other. This shows that the condensation happens on the walls, but it doesn't happen in the atmosphere inside the jar. It happens on the walls, but it doesn't happen in the atmosphere inside the jar. Part 2, we put some ice cubes in the lid of the jar. It helps if you start with a fresh cup of hot water. Then we light a match. This is something I want you to be cautious of. If you're working at home, you'll be cautious of hot water, but you'll also be cautious of a match because it can start fires. When we start a match, we are not making the jar full of smoke. Just a few smoke particles inside the jar will give those water molecules that are in the atmosphere of the jar the opportunity to condense on what we call a nuclei, something that for it to grab hold of, and more droplets of water will attach to those little tiny bits of smoke, and that forms a cloud. There's a third factor we haven't connected yet. The factor is pressure. Pressure. We talked about the layers of the atmosphere and how there's more particles in the lower layers, and they have a pressure from the upper layers pushing down on them. Greater pressure contributes to condensation. If I try to boil water high up on a mountain, I have actually fewer air particles pressing down. There's less pressure, and it actually changes the way the water boils. It's more difficult to create condensation, to create a cloud, but it's a lot easier to boil the water. If you cook at high altitudes, say you're going on a camping trip and you're boiling some water for tea first thing in the morning, the higher you get, the lower the boiling point. Normally, the boiling point of water is 100 degrees Celsius or 212 degrees Fahrenheit. That is the boiling point of water. If I go up in elevation up to, say, the top of Mount Everest, boiling point of water turns to 70 degrees Celsius. It drops because there is less pressure holding that stuff into the liquid state. That water that's in the liquid state, part of the reason it's in the liquid state is because of all of the pressure that's on it from the atmosphere. Once you go in higher elevation, you have less atmosphere pushing on it, you have less pressure keeping it in the liquid state, and it is ready to go into the water vapor gaseous state. If on a different camping trip, I go down to the lowest point on Earth, the bottom of the Dead Sea. The Dead Sea is actually a dry basin that is the lowest physical point on Earth. Oh, that's still dry land. My water temperature that I need to raise the temperature of the water in order for it to boil is actually 101 degrees Celsius. I have to put more heat into it to break that pressure that's put on by all of the layers of that atmosphere. You want to think about pressure keeping the molecules together. If you don't have enough pressure, the molecules spread apart. If they're spreading apart, they're no longer a liquid, they are now a gas. On the other hand, if you have more pressure, you put more pressure on something, those molecules that are floating around as a gas, as a water vapor, they are coming together and becoming liquid. Even more pressure, you can push them into a solid state. And water is not the only particle that follows these rules. Anything that is made of matter goes through these states of solid, liquids, and gases, and they respond to different levels of pressure. If you're carrying around an oxygen tank, you might have one that has actually increased the pressure and pushed that oxygen gas down into a pressure of 2,200 pounds per square inch. That's a lot of pressure. The other type of oxygen tank is in liquid form. The oxygen is cooled to bring it closer together to the point that it's negative 300 degrees Fahrenheit. Negative 300 degrees is actually the boiling point of oxygen. So that is bringing it down to that point, that dew point of what would it be to make that oxygen a liquid. So negative 300 degrees, it is right at the point of becoming a liquid into a gas. It's right in the middle. That is where they compressed it to. That's where they made it take up the least amount of space that they could. Once you release the valve and the pressure is off and the temperature gets to warm up, then both of those tanks will release that gas and it will push out that gas as it comes up to room temperature. Any substance has a phase diagram that tells you how to get it from the different states of solid, liquid, and gas, and you're doing that by changing either the temperature or the pressure, and sometimes both. If you have a solid and you want to create a liquid, you need to increase the temperature. If you have a gas and you want to create a liquid, you need to decrease the temperature. If you have a solid and you want to create a liquid, you could also lower the pressure. Less pressure means that those particles are going to be able to spread out and turn into a liquid. Same thing goes for a liquid. If you want to turn it into a gas, decrease the pressure and those particles will spread out. Temperature and pressure are keys to changing states of matter. Check out these links to learn more about changing states of matter, making clouds, and boiling water.